Hello everyone, Monty the Tutor here, and today we're going to be talking about the mean value theorem and Rolle's theorem from AP Calc AB. I'm very sorry for my extended leave. I was pretty busy. My senior year of high school has started. I've been doing college apps, just been a little bit busy since the summer, and I realized now it's probably definitely time to get back. And so today I kind of just want to talk about what Rolle's theorem and the mean value theorem actually are. So let's get into it. So let's start with Rolle's theorem. Uh, Basically, what Rolle's theorem says is that if a function is continuous on the interval of a to b and differentiable, I say diffable when I write it out just to save some time, and it's diffable or differentiable on a to b, and along with that, f of a equals f of b, then there is a place in between a and b where f prime of c or the derivative is equal to zero, which is essentially just fancy words for saying that this function has to turn around. So let's say with a quadratic, right? Let's say we have something like this, okay? Let's say our interval was, let's say this is like 1 and this right here is like 7, right? Let's say our interval, oh, I'm sorry, I take that back. Hold on. Let's say, sorry about that. So let's say this was 7 and this is 1, and it asked us, oh, can Rolle's theorem be applied to the interval of 1 to 7? Well, that's just saying that at some point in this line of, since f of 1 and f of 7 are equal, it's continuous from a to b, and it's also dysfunction differentiable on a to b, the open interval of a to b, then that means at some point in between point A, which is 1, and point B, which is 7, that there has to be a point C where the what's it called? The derivative is 0, which it is in this case. The slope at the very peak right here is it's a max, so it's 0. That's basically just what it's saying. It's a fancy way of saying that. And now let's talk about the mean value theorem. So the mean value theorem is a little bit similar to Rolle's, but just not exactly the same. So it still has the same conditions of if f of x is continuous on, sorry, closed interval of a to b, differentiable on a comma b, then there's no third condition here. Then that means there is some place where f prime of c is going to be equal to f of b minus f of a all over b minus a, which basically is saying that at some point on a function, let's say we have something like this, right? At some point on a function, let's say we have point b right here, or this is a, and let's say that right here is b. And if we draw the average rate of change from those two places, so from where it reaches right here, that means at some point along that average rate of change line, which is the secant line because it goes through 2 points, there is a line that has the same slope on it somewhere in the interval. And it looks like it's somewhere along this, basically. Like, sorry, I guess that's definitely in the wrong place. Uh, Sorry. But you guys kind of get the point. It's around, let's see, it's basically around, okay, I'm messing up, but it's somewhere, it's like this line right there. But that's basically what it is. MVT and Rolle's theorem, the mean value theorem and Rolle's. It's essentially the same thing, but one of them, basically Rolle's only works for a 0, but MVT kind of works for anything in that case. But one thing you have to keep in mind is all of these conditions have to be met. If something isn't continuous on that closed interval of a to b or differentiable on that open interval, it doesn't work. So, for example, if you thought you could apply this to the tangent function, let's say, or let's say, that means we have some asymptotes, right? and it goes like this. Well, if you apply it on the interval in between your asymptotes, then it won't. It actually still won't work because you have your closed interval here. But no matter what you kind of do with this, unless it's like very much in between the asymptotes, it won't work. Because if you include the asymptotes, it's not going to be continuous on that interval, and it also won't be differentiable because you can't be differentiable at that asymptote. But yeah, so that's basically what it is. Um, let's do a few problems to kind of see how these work in action, and you guys will kind of see. So let's move down. So this question is basically saying, determine whether Rolle's theorem can be applied to f on the closed interval a to b, and then also and then find the c if it does apply. So our function here is f of x is equal to negative x squared plus 3x, and our interval is on 0 to 3. So before we can start this problem, we have to check does it work? Okay, can we actually apply Rolle's theorem here? So let's see. This is a polynomial. This is a This is a quadratic, which means it is continuous. There's no asymptotes. There's no holes here. So that means we say f of x is I just say cont, but it is continuous. It's a continuous function in the closed interval of 0 to 3, right? We know that. And now let's figure out what the derivative of this function is so we can see, is it differentiable on the open interval of 0 to 3? So f prime of x is equal to negative 2x plus 3, which is a linear function, which means that it is also differentiable on this interval. So f prime of x is diffable on the open interval of 0 to 3. Lastly, we need to check so far if f of b equals f of a. So in essence, does f of 0 equal f of 3? So f of 0 is going to be equal to negative 0 squared plus 3 times 0, which is 0. F of 3 is going to be equal to negative 3 squared plus 3 times 3, which is basically negative 9 because we do the square, and then negative plus 9, which is equal to 0. So f of 3 does equal f of 0. So Rolle's theorem can be applied here. So now let's figure out where our value is 0. And basically all you really have to do at that point is just solve your derivative for where it equals 0. So f prime of x is negative 2x plus 3. Let's see where it's 0. So we solve this. 3. X is equal to 3 over 2. And that's where it is. So that means on this function of negative x squared plus 3x, at x equals 3 over 2, you will have a derivative of 0, basically. Your slope will be 0. But yeah, so that's what that is. Let's move over to a Rolle's theorem question so you guys can see how that's in action. So, let's move over to an MVT problem, mean value theorem problem. So, basically, we are asked to determine, can we apply the mean value theorem to f of x is equal to 6x cubed on the interval of 1 to 2. So, let's see. So, off the bat, we know it's a cubic function, which means that f of x is a continuous function on 1 to 2, which it is. Now, let's figure out the derivative and see if that's the same case. Now, we know that the derivative will just be 1 power lower, so it'll be a quadratic, which means we know that it will be differentiable, but you should find it out because we're still going to have to find out either way. So the derivative is 18x squared, which is, so f prime of x is differentiable on the open interval. Sorry, let me move this over here. On the open interval of 1 to 2. So both our conditions have been met because MVT only has these conditions. So now, that basically means that somewhere in between this interval of 1 to 2, we have a value where that tangent line is equal to the average rate of change, or the secant line between 1 to 2. So let's figure that out. So how we would do that is we would do 18x squared is equal to I'll write f of b minus f of a over b minus a. But if you replace the numbers, we have it as f of 2 minus f of 1 all over just 2 minus 1, which is just 1. So let's solve it. So our original function is 6x cubed. So that means we would have 18x squared. It's going to be equal to f of 2 here would just be 2 cubed is 8, so 48 minus 6 all over 1. So 18x squared is equal to 42. So now we just take it over, 42 over 18. We can simplify by 2, so x squared is equal to 21 over 9, and then square root both sides. And what we're left with x is equal to square root of 21 over 9, which if we check, let's see, so square root of 21 divided by 9 is between 1 and 2. So let's what's it called? That's basically what it is. So if we were to graph this, at this point, the what's it called? Sorry, the slope of the slope of the tangent line at that point would be equal to the slope of the secant line of the average interchange between f of 2 and f of 1. But yeah, I hope that helps you guys out, and hopefully that gave you a little bit of better understanding of Rolle's theorem and the mean value theorem. And I'll catch you guys next time.